what is an ordinary differential equation? Well, this E of equation, it means that we're using the equal sign, right, at some point. So we're saying that there is something expressed, in general, we're going to say that it's expressed in terms of the two letters that appear on the left-hand side. So this is also going to be a big deal. So left-hand side, left LHS, I'm going to use that a lot, and then right-hand side of relative to the equation, okay? So I could write this very much the same as dy dt, and if I do that, I'm assuming that y is a function. By writing this, I'm assuming that then y is a function of t, and therefore I take the first derivative of t, right? And then I could write here f of t comma y instead of x comma y. So if we have such expressions, right, we have an expression, for example, dy dx equal, this one, let's go easy here. So let's say 1 times y. This expression says that the derivative of a function y assuming that y is a function of x, is equal to the function y. What? The derivative of a function is equal to the same function. Now, what? So it turns out, let's think about derivatives of functions, okay? So what is the derivative of cosine of x? And what is the derivative of sine of x? Cosine of x. If only that negative were not there, this thing would be super, it would be really nice, because this one is the derivative of the other one, and then you differentiate again, and then you are back to what you started with. But the cool thing still, even with that negative there, is that the derivative operators of these two functions are kind of sending one function to the other, and then to a multiple of the other, and then returning back. All right, so how about the derivative of the function e to the x? The derivative of the function e to the x, excuse me, what was that?
Is e to the x.
E to the x, thank you, right? So the derivative of the function e to the x is e to the x, when derivative meaning that we're differentiating with respect to x. So that is, if we think that learning the derivatives of sine of cosine is easy or straightforward, you can definitely not complain about learning the derivative of e to the x is super easy, because there's nothing to learn. The derivative of that function is the same function. So this is exactly what is implied when we write that same type of thing in this form. We're saying we need to, so we're saying the derivative of y with respect to x is equal to y. So that would be that y of x equals e to the x. So I guess what I'm bringing to your attention is you can write an expression of this type, separated by an equal sign. Therefore, that's an equation. It is no longer an equation of values. Some of you are knowledgeable of linear algebra. In such case, you know everything there is to know about solution sets of linear systems and vector spaces and that kind of language. I only say that because I recognize names and faces. But some of you, okay, so linear algebra, very interesting stuff. It has to do with finding solutions to equations. They're not necessarily equations of values. In linear algebra, values are called scalars, of specific numbers. The first type of equations we learned to solve were linear and quadratic equations, and the whole game there was about finding sets of values. One value, two values, things like that. Well, turns out that these are equations, things being equal to each other. The solutions of these equations are no longer values, but they are functions. The solutions are functions. And what does it mean for a function to be a solution of a differential equation? Okay. So I'm going to call this equation here 1. All right? So I'm going to say function y of x equals e to the x is a solution to the ordinary differential equation 1 because when we compute the derivative of y of x is e to the x. In other words, e to the x is y. So what I just did there, maybe you think this is boring, is because the equation, the O.D.E and the solution is quite simple, relying on the fact that the exponential function has the property that is exactly equal to its derivative. In fact, if you remember now, if you're, this brings to your attention, yeah, those are some sound effects that we have in this classroom. So y prime equals y. The exponential function has a property of being the same as its own derivative, but the integral of the exponential is also a sweet deal, right? So based on the same fact, the integral of e to the x is e to the x. So what we just did there in those two lines is something that we're going to refer to as verification. So if there is a function which we claim is the solution, if there is a function which we claim is the solution to the differential equation, when we differentiate that function, we should be able to recover the equation. So verification is that the function, this means that the function satisfies the function satisfies the ordinary differential equation, right? So y prime equals e to the x, which is equal to y. This is the same as writing y prime or writing dy dx. Okay, this is a very, very basic notion of what is a differential equation. It's an expression involving a derivative and involving an expression in terms of the function. And if such function exists that satisfies that expression, we call that function the solution of the differential equation.